Hey everyone, and welcome to what is KIC 8462852. KIC 8462852 is the technical name given to a star that rose to prominence in the news in 2015 due to a peculiar dimming that happened to the star on an irregular basis. It's also been given two informal names: Tabby Star, after the lead author of the paper outlining the dimming, Tabby S. Boyajian, and the WTF star, with WTF standing for Where's the Flux, or What the F. For the sake of convenience, for the rest of this video I'll be referring to the star as Tabby Star. According to the Where's the Flux paper, which will be linked in the description, Tabby Star is a regular main sequence star, much like our Sun, with a spectral class of F35 or F3V, meaning it has a slightly higher mass and temperature compared to the Sun, and it has no companion stars. It's located 1,480 light years, or roughly 454 parsecs away, in the constellation of Cygnus. Tabby Star was one of the stars studied by the Kepler Space Telescope, whose aim was to discover exoplanets, planets that orbit other stars, through the transit method. The transit method is looking for a dimming in the star's light when a planet passes in front of the star being studied. According to the mission overview page of the Kepler Mission, the transit allows information about the planet to be calculated, such as the size of the orbit and the mass and the size of the planet itself. More information can be worked out, but I'll leave it on the mission overview page, which check out yourselves. The peculiar dips were discovered by regular people on the Planet Hunters website, which is a website where people can go to help look for dimming of planet stars using data gathered by the Kepler Space Telescope. So what's so special about the dimming of Tabby Star? Typically when exoplanets have been detected, the produced light curve is similar to what's seen on screen with Kepler 5b and Kepler 6b. These show a dip in the star's light of about 1 to 2%, and this is for planets the size of Jupiter and bigger. Also, the dips are both smooth and regular. Smooth meaning that the dip starts, moves directly to the bottom of the curve, then the climb back up is near identical to the fall, except that it is in reverse. With regular, I mean that the dip for that planet pops up when it's expected to at regular intervals. With Tabby Star, these dips veer drastically from that. On screen are two of the graphs from the paper linked in the description. The upper graph shows the full extent of the dipping and the magnitude of them, and the lower graph is a zoomed in version of the upper graph with a few of the bigger magnitude drops cutting off at the bottom. They cover about 1600 days, or about 4.38 years of study. The important details are as follows. The magnitude of the dips vary from 1 to 2% up to 15 to 20% of light blocked. The dips themselves aren't all smooth in and out like the typical dips from other stars. Some of Tabby Star's dips are in and out like other planets around other stars. Others start dipping, then start rising again, then dipping even further down, indicating that even more light has been locked. They're also irregular, which don't appear to pop up on a regular basis. They happen almost at random times. In essence, these dips and changes differ wildly from what you would expect from regular planets travelling around a star. If you want to look at the graphs closer, as well as see close-up versions of those various dips, check the Where's the Flux paper in the description. All the graphs are on page 4, with the description of them starting on page 3. So what's causing the dimming? The short version is we don't know for certain. We're still studying it, getting more information, but there are hypotheses out there. The paper itself has several hypotheses, including planetary collisions and swarms of comets. These are variations of naturally occurring events and could explain the dimming while expanding our knowledge base. They aren't without problems though, such as the likelihood of us catching any planetary collisions being incredibly low, and there being no excess infrared light for collisions in the asteroid belt of Tabby Star. Not in the paper though, but still a popular hypothesis, is the alien megastructure hypothesis. Aliens building what is called a Dyson sphere or a Dyson swarm, giant structures in space around stars, in this case Tabby Star. While this probably would explain the dimming, peculiar dimming, it's not without its issues, such as no detectable communications such as radio waves coming from the area around the star. While I don't and can't say for certain what's causing the dimming, personally I'm hoping that it's aliens, yet I'm expecting it to be something relatively mundane. So that's it for this video. Links to various articles and web pages that are relevant to Tabby Star will be in the description below if you want more information, and which I advise because they can go into more information than I can in this video. If you have any more ideas or suggestions for the What Is series, let me know in the comments below. If you want to see more from this channel, please hit subscribe and like, and typically what else you'd ever do. Anyway, I'll see you all in the next video. Bye everyone.